Suppose you roll a standard six-sided die, this one right here. Your outcomes are 1, 2, 3, 4, 5, 6. Question number 1, what is the probability of rolling a 5? Question number 2, what is the probability of rolling a 5 given that the result was a number greater than 3? So this is an extra piece of information given to you, an extra evidence. So are your above answers, are they same or are they different? If they are same, why are they same? If they are different, why are they different? These types of questions are answered by conditional probability. This session is about conditional probability. By the way, the answer for this is 1 over 6, and the answer for this is 1 over 3. So let's review the definition of probability real quick. So the probability of an event E is defined by this expression. It is equal to the number of favorable outcomes divided by the total number of possible outcomes. If omega is your sample space and E is a subset of omega, then the probability of E is given by the size of your event E divided by the size of your sample space. Let's understand this through a simple example. Let's say in a two-coin toss, the question is, what is the probability of getting both heads? Well, here my sample space is head, 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 tail, 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 right here. Okay, these are my samples elements in my sample space, and my size of my sample space in this case is 4. The event E in this case is that both tosses are head. There's only one element over head, head, which is this right here. So my size of my E in this case is 1. So the probability of E is going to be 1 over 4. I'm just using this expression right here. So the conditional probability of an event B, given that another event A has already occurred, is the probability that B happens under the condition that A is known to have occurred. It is written like this: P, B, and there's a vertical line in between B and A. Mathematically is defined with this expression right here. My numerator, this one right here, it is called the probability that both A and B occur together. The denominator, which is probability that your A occurs, and it is always going to be a positive number. So this formula right here, it essentially tells us how to update our probability of B when we know that A has happened. So you have a PB, okay, and then you are known, somebody tells you, hey, I just observed an evidence A. So A in this case would be called an evidence. So you observe an evidence A, and based on the observation of evidence A, you will update your probability of B. And so this will be written as probability of B given that A has happened. So in this case, probability of B is another name for that is a prior probability of B, and probability of B given that A is called posterior probability of B. Prior means before updating based on the evidence A, and posterior means after you're updating based on the evidence A right here. So suppose you roll a standard six-sided die. Question number 1, what is the probability of rolling a 5? Question number 2, what is the probability of rolling a 5 given that the result was a number greater than 3? So let's do question number 1 first. Here, my sample space is given by these numbers 1, 2, 3, 4, 5, 6 right here. Okay, and B, let's say it's an event where you get 5. So B in this case would be 5, which is right here. This is my B. So the probability of B would be equal to the size of B divided by the size of your sample space. My size of sample space is 6, size of B is 1, so 1 divided by 6 is my probability of B. Okay, now let's do question number 2. Now we are given an additional piece of evidence and another piece of information. And that is this: the result was a number greater than 3. So let A be an event where your result was a number greater than 3. So we have to find probability of B given that A has happened now. So here my A would be 4, 5, 6 because the event that the result was number greater than 3 is these are the only possibilities. My A intersection B in this case would be 5. So if this is my A right here, 4, 5, 6, and my A intersection B is this right here, 5. So 5 is the common element right here. Okay, so the probability of A would be given by the number of elements in your A, which is 3. There are 3 elements over here. Divide by the total size of your sample space. 3 over 6, answer comes out to be 1 over 2. Now let's calculate the probability of A intersection B. Well, that would be equal to the size of your A intersection B. In this case, there's only one element. So 1 divided by 6 is equal to 1 over 6. Okay, so I know my probability of A. I know my probability of A intersection B. Now let's calculate our probability of B given that A has happened. I'm using this formula right here. So substitute your values in there and the answer will come out to be 1 over 3. So conclusion, the original probability of rolling 5 is 1 over 6. So this was my original probability of B. Now knowing that the roll was greater than 3, okay, so this was my evidence. Okay, this is my evidence. It changed the possible outcomes and therefore the probability. The new probability now increased to 1 over 3. So this was my probability of B initially. I got some new evidence and based on the new evidence, now my probability of B, given that A has taken a place, it changed now. So this was originally 1 over 6 and now it became 1 over 3 based on this evidence. Suppose two dice are rolled. Question number one, what is the probability that at least one die shows a 5? Question number two, what is the probability that at least one die shows a 5 given that the sum is 8? Question number three, what is the probability that at least one die shows a 5 given that the sum is 15 now? So here, my sample space is shown in the figure towards the right, this one right here. So the way you read this is, let's look at this one right here, 3, 2. In this case, it means that you die 1, you got 3, and you die 2, you got 2. Okay, uh, so let B be the event where at least one die shows a 5. So in this case, your event B would be this right here. This right here, all these possibilities are where your at least one die shows a 5, and another one would be this right here. So these two are my event B. So what is the size of my B in this case? It's 12. There's 6 over here, 6 over here, total 12. So the probability of B is going to be 12 over 36, and the answer is 25%. So that's the probability of B. Question number two. Now we are given an additional evidence, an additional information that the sum is 8. So let A, let me use a different marker now. So let A be the event that the sum is 8. We have to find probability of B given that A has taken place. So in this case, my A is that the sum is 8. So all the possibilities where your sum is 8 is these numbers right here. 6, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, and then all the way like that. So these are my event A right here. Okay, so the probability of event A would be 5 over 36 because there are 5 elements total in here. 5. And probability of A intersection B would be the common elements between A and B. So this is my A and B, and the common elements are this right here, 5, 3, and 3, 5. So these are the intersecting elements. So in this case, the probability of A intersection B would be 2 over 36 because there are 2 elements that are inside A intersection B. Okay, so the probability of B given that A, now I'm going to use this equation right here. This equation, you know your probability of A intersection B, you know probability of A, putting the values in that equation, your answer comes out to be 40%. Conclusion, the extra piece of information, the evidence A, which is this right here, it changed the probability of B. In other words, it actually increased. Let's do question number 3 now. So let A be the event that the sum is 15. Well, this is not possible. Okay, there's no way you can get 15. You can check all the possibilities. There's no way you can get 15. The maximum you can get is 12 from here. That's it. So in this case, probability of A equal to 0. So the probability of B given that A is not defined. Remember, it is only defined when your PA, or probability of A, is greater than 0. So two dice are rolled. Question number one, what is the probability that at least one die shows a 6? Question number two, what is the probability that at least one die shows a 6 given that sum is even? So let's do question number one first. Let your B be the event that at least one die shows a 6. In this case, your possibilities are these ones right here. Okay, here you can see at least one die shows a 6. This one is 1, and then there is this one right here. This is my event B. So in this case, the probability of B would be 11 over 36 because you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 elements total. So it's going to be 11 over 36, which comes out to be 30.5%. Now, let's do question number 2. Now we are given an additional evidence and another information that your sum is even now. So let A be the event that your sum is even. So in this case, we have to find property of B given that A has taken place. And we'll be using this formula right here. So for the to use this formula, you need to know the numerator and the denominator. Okay, so let's calculate our A first. There will be total 18 elements in total. You can actually check. Your A is that the sum is even. So in that case, let me use a different marker. So in that case, your sum is even. Your possibilities are this, this, this. Then over here, it's going to be this one right here. It's going to be this one. It's going to be 5 plus this one. And then you can keep going like this one, and this one, and then come down over here, you're going to be this one and this one, this one, and this one, this one. I think you got an idea now. So these are all your possibilities where your sum is going to be an even right here. Okay, so this one, these are all my A. Okay, this is my additional information. So how many elements we got total over here? 18. You can count. There's a 1, 2, 3, 4, 5, 6, total 18 elements. Okay, so A intersection B in this case would be your 6, 2, 6, 4. So all these elements, this one right here is A intersection B. This is also A intersection B. This one, this one, this one. They're total 1, 2, 3, 4, 5 of them. So in this case, probability of A intersection B would be 5 over 36. And likewise, probability of A would be 18 over 36 because there are 18 elements in A. So now you can use your formula and substitute your values in there. I'm just using this formula right here. Okay, and the answer comes out to be 27.8%. Conclusion. So the extra piece of information, the evidence A, it changed the probability of B in this case. Here, it actually decreased. Imagine a square dartboard that goes from 0 to 1 along both the x-axis and y-axis. So this is your square dartboard that goes from 0 to 1 along x-axis and 0 to 1 along your y-axis. So this is your visual representation. So every dart that you throw, it lands uniformly at random on the board. In other words, the probability of landing in a region is proportional to its area. So if let's say this is your region right here, the probability that it lands over here would be equal to, it's proportional to its area. Question number 1. What is the probability that it landed on the bottom left quarter of the board where your x is less than 0.5 and y is less than 0.5? In other words, what is the probability that it landed over here in this region? And this point right here is 0.5 and this point is 0.5. Question number 2. What is the probability that it landed in the bottom left quarter of the board where x is less than 0.5 and y is less than 0.5, given that this additional piece of information that the dart landed below the diagonal line y equal to x. So you have to find the probability that the dart landed over here in this region, given to you now an additional piece of information that the dart landed below this diagonal line somewhere over here. So this is your A right here. Okay, let's do question number A first. Let B be the event that the dart lands in the bottom left quarter, which is right here. Now we know the probability is proportional to the area. So the probability that the dart landed in region B is equal to the area of the bottom left quarter divided by the total area. And the bottom, this right here, the area of this region is 0.5 multiplied by 0.5. So 0.5 times 0.5 and the total area is 1 because this is from here to here is 1 and from here to here is 1. So the answer comes out to be 0.25. In other words, 25% chance that the dart lands in this region right here. Okay, now let's say we are given an additional piece of information. This right here. That the dart landed below the diagonal line y equal to x. So this is given to you. It lands somewhere over here. All right, so that has eliminated this part completely, right? So you would imagine that they probably should go down. So let's see if it makes sense. So let A be the event that the dart landed below the diagonal line y equal to x. So let's say this is my event A, that the dart lands over here in this region. Now we have to find probability of B given that A. In other words, I have to use this expression, right? This equation to find this. So in order to find this, I need to know my probability of A intersection B, and I have to know my probability of A. So let's find probability of A intersection B. That would be equal to area of A intersection B. So this is my A right here, right? And my B is this. Let me use a different marker, red one. So this is my B right here. So A intersection B would be this part right here, this region. Okay. So the area would be 0.5 times 0.5 times 0.5. Basically, I'm just using that formula, half times base. In this case, my base is 0.5 times height, which is 0.5. And this is how I got this expression. Solving it, the answer will come out to be 0.125. So this is the probability that your dart lands in this region right here, A intersection B. Now, the probability that the dart lands in A is equal to the area between the diagonal and the bottom. In other words, let me remove everything now. The probability that your dart lands in this region, oops, sorry, not this color, let me use different one. This region, that the dart lands in this region right here, is equal to the probability, is equal to the area of this region right here, okay, divided by the total area. And this area is 0.5 because my total area is 1, from here to here is 1, right? So, and this you can see is half of that, so it's going to be 0.5 divided by 1, and the answer is 0.5. Now substitute these values in your formula for probability of B given that A, and your answer will come out to be 0.25, which is 25%. So this extra piece of information, the evidence A, it did not change the probability of B. Your probability of B was 0.25, and now is still 0.25.